Take a look at your opener here. It says find the area of rectangle B if the two rectangles are similar. So first off, when you look at rectangle A, right, we can go and we can start looking. If these figures are similar, we know we can create our proportions. So we can compare our 5 to our 15. And we can compare our 4 to our x then. So we can get our proportions, so we can cross multiply and find that missing height of rectangle B. So 5 times x is 5x. 15 times 4 gives us 60. So when we divide both sides by 5, we get x to be 12. So to find the area of rectangle B, it is just 15 times 12. So our area here is 180 units squared. Now what we're going to learn today is we're actually going to be able to compare the areas of similar figures. If I look at my area of rectangle A, that area of rectangle A is 4 times 5, which is 20 units squared. So there's an important thing that comes up here. We have a scale factor of our rectangles. That scale factor is 5 to 15. Right? 5 to 15 is the same thing as 1/3. So rectangle B, I am multiplying by 3 to get my length. But if you look at your areas, that is not what you're multiplying by. 20 times 3 is not 180. That multiplier we're looking at, we have to remember what type of unit we're dealing with. When you deal with a length, this is 5 inches, for example, and 15 inches, for example. When you look at area, we have units squared and units squared. So we have to deal with that conversion squared. We said we were going to be multiplying by 3, so we have to multiply by 3 squared. So we're actually going to be multiplying by 9. Right? And that's what our theorem here today is going to say for us. Areas of similar polygons. If two polygons are similar with the lengths of A to B, then the ratio of their areas is A squared to B squared. So take a look at your first example. I want you to find the ratio shaded to unshaded of triangle ABC and triangle DEF. It says it wants the ratio of our perimeters. Well, let's start with our sides. Our sides are measured in plain inches, plain feet. Right? So our sides, shaded to unshaded, we are looking at 9 to 6. So our sides is 9 to 6. We learned earlier this year the ratio of your perimeters is the same as the ratio of your sides. So the ratio of my perimeters will also be 9 to 6. The ratio of your areas then, right? Ratios reduce. So 9 to 6 reduces to 3 to 2. 9 to 6 reduces to 3 to 2. So for my area, then we are going to square that ratio. So 3 squared is 9. 2 squared is 4. So we have a ratio of 9 to 4 then for our areas. Taking a look at your next example then, it says you buy 2 rectangular pieces of aluminum window screening. One is 15 feet long. One is 15 feet long and costs $135. The other is similar in shape and is only 20 feet long. So the screen is sold by the square foot. What is the cost of the longer roll? So right now we know our scale factor. Our scale factor is 15 to 20. Now keep in mind we were doing the small to the large here then. We do it as 15 to 20. 15 to 20 reduces to 3 to 5. So there's our scale factor. the ratio of your sides is 3 to 5. The ratio of our perimeters would also be 3 to 5. What we just learned then is the ratio of our areas then is 3 squared, which is 9, to 5 squared, which is 25. Now the key here is you have to read the directions. They tell you that this screen is sold by the square foot, which means we want to use our area ratio. So the ratio of our areas here, we said was 9 to 25. That will be equal to the price of each. Well, the price of our small one, they told us, was 135. Remember, small is on top in our ratio. So we're going to have 135 over x. And once again, we'll cross multiply. 135 times 25 gives us 3,375. 9 times x is 9x. Divide both sides by 9. We get $375. Right? Looking at your next example. It says given triangle ABC is similar to triangle DEF, find your ratio shaded to unshaded of your perimeters and your areas. So the ratio of my sides, shaded to unshaded, is 12 to 15. 12 to 15 reduces to 4 to 5. That means the ratio of your sides is 4 to 5. The ratio of your perimeters will also be 4 to 5. The ratio of your areas then is 4 squared, which is 16, to 5 squared, which is 25. Second one here, it says suppose, or in example 2, which was our window screening problem. So we have a 15-foot piece and the 25-foot piece. So suppose you decide to buy a different kind of screening, but in the same dimensions. The longer roll now costs $200. Wants to know what is the cost of the shorter roll. So once again, we look at the ratio of our sides. The ratio of our sides is 15 to 25. Which reduces to 3 to 5, which means the ratio of our perimeters is also 3 to 5, and the ratio of our areas is 9 to 25. Once again, it is still sold by the square foot, so the ratio of our areas, we're going to use 9 over 25. Now we do not know the shorter roll, but they're saying the longer roll will be 200. Once again, we'll cross multiply. 200 times 9, we get 1,800. 25 times x is 25x. Divide both sides by 25, we get x to equal $72. So there is the price of our shorter roll. All right, take a look at your next example then. It says a large rectangular billboard is 12 feet high and 27 feet long. So the smaller billboard is similar to the large billboard. The area of the smaller billboard is 144 square feet. Find the height of that small billboard. So first thing we need to figure out is the area of our big billboard. That way we have something to compare, right? We know the length of our big billboard, but we don't have the length to compare over here. We know the height of our big billboard, but we don't have the height over here to compare it with. All we know from the small billboard is our area. So we need to figure out that area of our big billboard. 12 times 27 gives us 324. Right, so the ratio of our areas now is 144 to 324. If I reduce 144 over 324, we get 4 over 9. If the ratio of our areas is 4 over 9, we need to figure out the ratio of our perimeter and the ratio of our sides. Area is in squared units. We need to get back to plane units. So we are going to square root those values. So the ratio of your sides will be the square root of 4, which is 2, over the square root of 9, which is 3. It'll be the same thing for your perimeters then. And that's where we're going to get our values from. We are trying to find and work with our sides. So we need to use the ratio of our sides. The ratio of our sides is 2 to 3. So I'm going to do 2 over 3 equals now. What are we asked to find here? Are we asked to find the length or the height? So in this case, we are asked to find the height of the smaller billboard. So we want to match it up with the height of my larger billboard. So that ratio that we have of 2 over 3, we do not know the height of our small billboard, but the height of our big billboard, we just said was 12. So once again, we'll cross multiply. 3 times x is 3x. 2 times 12 is 24. We divide both sides by 3, so we get x to equal 8 feet. All right, 2 more problems here. First one says a stop sign rug is a regular octagon. Means all the sides are equal. So it says each side is 2 feet. With an area of 19.3 square feet. It says you make a stop sign mat with a perimeter of 72 inches. Now, in an octagon, there are 8 sides. So that tells me that each of these is going to be 9 inches long. Right? Now, the other thing we know is since each of our sides of our stop sign are equal, the perimeter here, 2 feet, is going to be 16 feet then. 8 times 2 gives us our 16 feet. So we have the area of our big one. We have a side of our big one. We have the perimeter of our big one. We have a side of my small one, and we have the perimeter of our small one. The problem is I am not in matching units. So if I change my perimeter, 72 inches, if I change that into feet, my perimeter we are looking at is 6 feet. 9 inches, that doesn't change the feet very nicely. It's 3/4 of a foot. So if I'm looking at nice numbers to compare, let's compare the perimeters because they're nicer numbers to work with. So the ratio of our perimeters is 16 feet to 6 feet, which does reduce to 8 to 3. That means the ratio of our sides would also be 8 to 3. And the ratio of our areas then will be 8 squared, which is 64, over 3 squared, which is 9. They ask us to find the area of our map to the nearest 10. So we are going to use then the ratio of our areas. So 64 to 9 will equal my two areas. We know the area of our big one was 19.3. We're trying to find the area of our small one. Now, in this problem right now, we've converted everything to feet. So we will have to keep that in mind when we go to get our answer. Cross multiply 19.3 times 9 is 173.7. 64 times x is exactly that, 64x. Divide both sides by 64. We get x to equal approximately 2.7. Now, the issue is, right now, we converted everything to feet. They want it to the nearest square inch. Likewise, when we are converting here, normally feet to inches, when you do feet to inches, we multiply by 12. When you do feet squared to inches squared. The whole point in this lesson is to remember, we have to square our conversion also. So we should be multiplying by 12 squared here, which is 144. So to convert my 2.71 feet squared to inches squared, we need to multiply by 144. 2.7 times 144 gives us 388.8 inches squared. Brings us to our last problem then. It says rectangles 1 and 2 are similar. The perimeter of rectangle 1 is 48 inches. Rectangle 2 is 30 inches by 18 inches. So first thing, all my units are the same. It says find the area of rectangle 1. All right, well, we can find the area of rectangle 2. That's 18 times 30. So the area of rectangle 2 is 540 inches squared. We can also find the perimeter of rectangle 2. 30 plus 18 plus 30 plus 18 gives us 96 inches. So when we're looking at what we can match up here, we can match up our perimeters in this case. I got 48 inches over 96 inches. 48 over 96 reduces to 1/2. So the ratio of my sides would be 1/2. The ratio of my areas then is 1 squared, which is still 1, over 2 squared, which is 4. Since we are asked to find an area, we will use the ratio of our areas. So I can do 1 over 4 equals the two areas. The area of my small one, we do not know. The area of my big one, though, was 540. So 4 times x is 4x. 1 times 540 is 540. Then we will divide both sides by 4. Giving us our smaller area to be 540 divided by 4, which is 135. Looking at our units, everything was in inches, so we are looking at inches squared. Right, which brings us then to your homework.